What's that?
We cuddled last night.
He's gonna redo it. Alright, take two.
She chucked it at my face and she wants me to give it back.
Because his name is Wolf.
I'm not being told.
Respect your siblings.
Respect
Respect your mom.
children. You two need to work it out.
We got
He owes me $10.
Okay, ready to do power?
Power!
So Cranes, I have a question.
Yes, sir.
In Dragon Ball Z, how would they equate the power level?
What? There's no way that can be right. Well, they've got to figure out how the rate of energy transfer would work
Do you
between.
watch Dragon Ball Z?
No. We were all like, what? It's over.
Okay.
There's no way that can be right.
Like coming out.
Wait, this is like
Cole, don't tell me you watch it.
Yeah, this won't be too difficult. But I don't want to say that because then everyone's like, Mr. Kramer, you said it wasn't going to be difficult, then it was really difficult. Yeah, but don't tell my parents on you, and then they'll cut your salary in half, even though you make nothing.
I'm just
So
waiting.
now you get a half a penny.
I'm waiting for the day when like a computer walks in and when Kramer's doing it.
I need to reset that.
I'm gonna show that to my mom.
I actually have never.
Okay.
You sound like a voice from something. I don't remember what it's from.
It sounds like something from Star.
This is not a long one. This is not. Okay. Okay.
Is it easy?
It's so easy.
Okay.
Like, it is like the easiest thing. You can like close your eyes and go to sleep and you will get it.
Okay. Then I won't stress as much. No, Isaac's actually gonna.
I told you that 2 days ago.
Yeah, I know. I was
Yeah, you guys have a quiz tomorrow.
It just didn't say quiz.
What? A quiz? I'm gonna totally complain.
Mom!
You guys know how to.
Hey, what's I?
Yeah, I know.
Hey, what's
I'm gonna get out of
Oh, thanks for asking.
We're gonna what's
You already said no.
Well, then I'll give it to you tomorrow.
Oh my god.
I already tried to say
Okay. Hey, fraternity. Power. So what power is how fast energy is transferred. Okay? What is the thing you're probably most familiar with hearing power in the context of physics, but in the context of what you might see or deal with
A
on a
power
regular
plant.
Okay? Horsepower, okay. I'll give you the actual horsepower in watts for you. Whoa. Because the typical unit for power is a watt. A what?
Not joules.
Yeah. So you want to know the unit for power? Just go what? What?
What?
What? It's a watt. Okay, where do you typically see wattage? Light bulbs, okay? So, listen, a light bulb with a high wattage is going to transfer energy more, making it have more light.
Some more energy.
Yep, per unit time.
That's why in Monster
We'll use watt.
Oh,
And so the whole thing now with like LED lights, and they just have come up with a more efficient way of transferring energy and getting light output. Because the old school lights, I don't know if you guys know this, but like the incandescent light bulbs, really what happens is they take electrical energy or electrons and they put it through a filament. And like in the light bulb you got your filament, that's an awful light bulb, but like you got like that, and electricity comes up and then there's this like little filament here. Okay? Well, what happens is that electricity goes from one end through this end and out. Well, this filament is an extremely resistive material. So those electrons, as they're going through there, it's resisting that motion so much. It's like really, really high. It's a really high friction material, essentially. And So what happens is you have those electrons that are going through a high friction, and what's happening? Heat. Heat, and enough heat produces light. So that's why when you touch those old light bulbs, they're really hot.
Heat produces light.
Well, yeah, it's two energies. I shouldn't say that. Heat doesn't produce light, but usually, yeah.
Only the old ones did that.
Okay, now the new lights, they have a more highly efficient, because what's happening is really you're just taking and losing a lot of energy in the form of heat and in the form of light. Okay, so it's not the most energy efficient way to light a room.
Oh, so that's
So
why
we should rewrite the
LEDs are a lot
light
more.
bulb thermostats are neon.
Yeah, and they're not hot. Like they're not losing a lot of energy in the form of heat. They're converting most of it in the form of light. So here's how this works. Power is going to be the amount of work that's done over time, or how much energy is transferred over a unit time. Okay? Now there's a couple other equations we can take, and we could, well, let me show you how I get to that equation. So power
So for instance, actually.
is work over a change in time. Don't we have an equation for work?
Yeah, work.
So couldn't we say power is really a force times a distance over time?
Yeah.
You might want to put that in your note card as well.
Cosine if there is one.
Oh yeah, you could put cosine, but we won't have to in this case. All right. Well then, isn't a displacement over time also known as? Okay. So there's really three equations you'll need. This one, power is force times distance over time. Or I could simplify this into a distance over time, or a displacement over time is velocity. So there's another form of the same equation. What was that? Yeah, so the unit would be a watt, and a watt is a joule per second.
Oh. A watt?
What? Joule per second. I can't do that. It's like a minion from Despicable Me. You did it.
I did that.
I haven't touched that.
Cool white bricky things.
Why is it so bad?
Man, I'm gonna call administration,
Call my
and I'm gonna
mom.
change your mom. And I'm I don't know. I'm just gonna reverse it on you guys. I'm gonna call your mom and just be like, hey, can you not give Cole naps anymore?
If I take
Take away his league account.
No food.
Oh, yeah, take it away. Let's do it, bro.
Not before I hit gold. The cornerstone of this. No, it's not.
Two problems here. We got plenty of time. Whoops.
Okay. Are they hard?
No, they're so. You're gonna be Cheyenne. I love you to death, but like sometimes it makes me want to shake the baby.
You really love her.
Roast.
Shake
price.
Because it's shy.
Shy.
So let's do this.
You guys will know when you have kids where that
Has
phrase
shaking
comes from.
concussion.
Shaken baby.
What, shake a baby?
Instead of shaken
Yeah.
baby.
There are times as a parent that you really want to shake a baby. Just tell me.
Shaking the baby.
But then you realize that's not healthy for the baby.
That's the third time I've heard you say that.
I'm serious. Every one of you at some point will be like,
I
I'm
highly doubt
Chelsea,
that.
100% bet.
I asked my dad that and he said it's.
You won't like actually think about it, but you'll be like, "Ugh, just- ugh,
No, I'm
stop crying! Ugh."
a child.
Cheyenne, get well.
Yeah, they're not so cute when they start crying.
I wanted to leave them in another room before.
Oh, I do that all the
I
time.
don't know. It's just the kids on the shoulder.
No,
As long as
that's
you
okay.
put it down with a little blankie, they're fine.
Yeah, let them
Okay, my,
No, I think parents coddle their kids.
So by your parents.
so we got these things.
Yeah, that's how it just turns out.
Yeah, we got baby in the
We believe it. We believe that if you really train your kids
My
how to
head is
put
face
themselves
down,
to sleep.
so I'm like this, and then I pass.
And she's like, you don't know.
You would wedge me.
Alright, ready?
Yeah.
Guys, so here we go. We got a certain curtain. Say we're about ready to do a play. You know, Nihilus came to me and he said, hey, I've got this 193 kilogram curtain. It needs to be raised. What? He comes to me and goes, hey, I got this curtain. It needs to be raised 7.5 meters. And I want it to be done at a rate that like it takes about 5 seconds to raise it so that, you know, there's a nice transition period and whatnot. Okay? And I'm like, all right, I can do that, Mr. Nihilus. Or we're like, my business class, we can do that. We'll choose a motor that will be able to use it, do this correctly. What is you tripped over my feet? Don't get your feet off of all right?
Cross your legs and whatever.
So it says, we've got 3 motors that we can use. We can use a 1 kilowatt motor. I can use a 3.5
You have
kilowatt
to
motor.
change kilowatts to
Horror of horrors.
Pillow.
I know, but it's still
Which motor is the best to use? So what we really need to do is figure out how much watts would need to do this over a 5-second period. And then figure out which one that would be closest, essentially.
Oh, yeah.
Okay? So we got a few equations here. Power is work over change in time.
Watts work.
What do you think it was?
I thought it was watts.
Okay, we can also say power is a force times a distance over change in time. We don't even have anything about velocity, so I'm just going to throw that out of the equation here.
Wait, why do you have both of them?
Let's just have them because force.
What is
We're going to use one of them. Okay. How do you think? Well, first of all, what do we know? Let's write down what we know.
Math.
Wait.
Wait, since it's going straight up, we know we can find the FN.
Why
You
do
do
you know
192
the math?
inches.
Which way?
Why do you even have conversions? Just put it in parentheses.
So it'd be 193 times. Just 3.
Okay, so based on these variables, what would be probably the most logical equation to
FD
use?
over CT.
Yeah, well, it's the same thing.
Or- Yeah, they are the same. You're right. Okay, I'm just going to do it all at once instead of solving for work and then plugging work in and solving the second equation. We'll do it all at once. I like doing that.
I like it.
Okay?
I like it.
Now what variable up here don't we have?
Force.
Force. Okay, so we need the force needed to lift the curtain. Okay? What would be the force that we would need to solve for to figure out how much force we would need to lift the curtain? Yeah, we would need to know, we would have to apply a force equal to the what?
Force of gravity.
Weight, yeah. Your weight. Because guys, if Cole stood up, if I tried to lift him, I would have to apply a force equal to his weight to be able to do
Would
it.
that be greater than his weight though?
Slightly, yeah. But we're gonna assume it's like right there because we could be, you know, we could apply a force way greater than his weight, but. So, remember, Fg equals mg is your equation for what?
Format force. Wait.
Force gravity. Because we said weight is really, by definition, the force that gravity pulls on an object. So if I want to overcome someone's weight, I have to have a force equal to the force of his weight.
So it's
Okay? So we should have mass in this context, 193 kilograms, 9.81.
Just crazy.
What do we get there?
it's like 141.
1/4?
That is 189.
I'm looking at it for one. I'm sorry.
189.
189.33. And then when you multiply that by 7 by
Okay?
then you get 141.
So now we're going to plug in here with our force and our distance and our time to figure out the power that I would need to get it to perfectly raise in 5 seconds.
Can you just like scale one of the bigger ones out?
See when you multiply that.
What is it, 7.5?
Yeah.
Okay?
Well, it's not.
What number do you get So 2,800 and what?
39.9.
Okay, and this is going to be in what? Okay, well we probably should change that to what?
Kilowatts.
Whoa. So now, do we have a motor that is specifically that wattage?
No.
No. So we know that if I wanted to raise perfectly in 5 seconds, I would have to have that specific motor. But we don't have that specific motor. So which motor would be probably do the best job? 3.5. Now, would that motor raise it faster or slower?
Faster.
It would raise it a little bit faster, so it might raise it in. We can actually figure it out if we wanted to. You want to do that? Okay, so let's say I've got, that would be 3,500 watts, correct?
Yeah.
That's going to be my power. We know our force is this. And then 7.5 meters. And then we're solving for the time. No, yes. Yeah. So you would take your force, your distance, and you divide it by your wattage. 0.25?
Nah, that'd be
That doesn't seem right. You got 0.25?
No,
Kilo,
it-
density, no, it's like base.
Can't be 0.25.
it's not. Yeah.
I don't know.
I got 4.05.
That's not right. 1893.3 times 7.5
4.05.
divided by 3,500.
That's what I did.
4.
What did we,
40.
400
I messed that up.
4.0.
1893 times 7.5
Oh, no, because then it would be.
divided by 3,500.
Oh, because then
Yeah, approximately 4 seconds.
Oh, because if I divide by the 0.2. Because I did the 1.5 with the other miles, and it would be 1 over 2.
Oh, you're gonna bring this up here, bring this down. So,
Most people count fast anyway, so it's fine. So it'd be 4 minutes.
yeah.
18 seconds.
Is that about what we said? About 4 seconds? If we
Yeah.
were to take it, now it's not perfect.
Well,
Mr. Niles might get mad at me, but I'm like, you know what? Give me some better motors and we'll be good with it. You know?
Motors,
You got like the
1.84 kilowatts.
And I'll be like, why don't you? Watch the video about what happened and
Huh?
I said it was interesting.
Next one.
Okay, Jesse White, judging him.
Yeah.
You're so judgmental,
You're
Justin.
so judgmental. Isaiah, thank you for saying that.
Hey, I don't have
Judgmental is
like that,
biblical.
Isaac.
Thanks, Isaiah.
You just get lost on YouTube.
Judgmental is this.
Take that, Jesse.
You can judge, it is biblical.
No, you can judge.
You
It's a
can.
roast on you.
No,
You
no,
can
I'm saying.
in a
Jesse
way,
always
but
said
not
I'm like.
You are very judgmental.
Judging is done.
Now, there is a healthy relationship between
There's
a
only
judging
one.
spirit and a loving spirit.
Same.
There's only one judge.
I said I'm not good at those, so.
relationship between Isaac and
Alright. So we got 2 horses pull a cart. Each exerts a force of 250 newtons. They both are traveling at the same speed. I don't know how that's possible, but sure. For 10 minutes. Calculate the power delivered by the horses. And how much work is done by the 2 horses.
We have
Yeah,
velocity.
we have velocity, don't we?
Maybe you don't. Never mind.
So do we have enough information to do force times velocity?
Yes.
Now what would the force be in this context? 500, because it would be the 2 forces pulling with an equal force as the sum of the 2.
Wait, how did you just get that?
It's driven.
Well, I have 2 horses each pulling this much.
Oh, okay.
Okay? They're both going at 2.0 meters per second, so we can assume it would be like 1 horse pulling with this much at this speed.
Is that how it works?
Wait,
I didn't think they
you
add.
have to do,
Perfectly.
What do you mean?
I think there's something in physics that they don't add perfectly. That's velocities.
We don't have
So like, if like the 2 meters, if you're, never mind.
If they both are moving at 2 meters, you're saying?
Like if you're moving on a train that's going 2 meters and you're going 2 meters on the train, you're not actually going forward by like 3.9 or something like that. I watched the video about something.
I don't know. Like you're saying, if you were also traveling
Like,
to,
relative to the train.
It is a Jewish
Oh.
The train.
you think they would?
I thought they don't add, but just wanted that.
There's always exceptions. I don't know. Yeah. I would assume they would. So, what?
I could have fixed it for so long.
Why?
10,
Right?
1,000.
How would we find the work? You would plug
1,000 equals x over 600.
So we know power is work over change in time, so solve for work since we know the power and we know the time. We gotta change 10 minutes to what though? 600 seconds. Okay? So your work is going to be your power
It's a whole lot of.
It should be
Whole lot of
times your time in seconds, which is 600 seconds.
Oh, wait, no, but this is work, this is in one place.
Wait, is it only one sequence?
Yeah, it's only one.
Ooh, then it'd just be.
Whatever.
600,000.
600. That one's supposed to be 1,000.
Beetle. No, look.
Oh, we got the.
There you go, one sig pig,
I divided
one sig fig. Happy?
600,000.
it. So Jesse, are we approving this whole
Got a question or
study group?
Yeah, because.
I'm really glad. What if you did a whole lesson?
We did.